Hello, Math Studies students, and welcome to your online lesson. Today's lesson will be on perimeter and area, which should be a review of things that you were introduced to and assessed on back when you took geometry. You may have even seen some of these concepts earlier than that, such as 7th or 8th grade. We will be applying formulas to find perimeter and area of two-dimensional figures, and our real goal here is to make sure that we're efficient. So if this is a review, we just want to make sure that we're really on top of it so that we can quickly and easily find perimeter and area of two-dimensional figures. Let's start with perimeter. What is perimeter? It's the distance around a polygon formed by contiguous line segments. So what do I mean by this word contiguous? Contiguous means connected. Like when we talk about the United States of America, we talk about the 48 contiguous states. Now there's 50 states, but Alaska and Hawaii are not connected to the other 48 states, but we have 48 of them that touch each other or are connected. Similarly, if I draw a polygon, I have 4 sides here that are connected. And if I know the length of each of those sides, I'm going to add up all those distances that go around. The distance of A, B, C, and D. And generally, we can do that just by adding up. Now, there can be shortcuts where we use multiplication, and we'll see that on some examples coming up. But for the most part, we are simply adding the sides of our polygon. Circumference is really just another word for perimeter. It's still a distance and it's still going around a figure, except this time we're dealing with a curved figure, such as a circle. And so we do have a formula that we want to use for circumference. And for circumference, which I will label as capital C, it equals 2 pi r. Now, pi is a special number, a little bit more than 3. We'll use the pi symbol on our calculator if we do want to round, and we won't plug that in until the very end of our work. We won't be using 3.14 in general for pi because that's already been rounded, and we like to save our rounding until the end of our problem to get the most accurate answer. And in certain times, we can leave pi in our answer so we don't have to round at all. But otherwise, we have this 2 and this r. And that should be familiar to us. When we talk about circles, a 2 and an r, 2 times r means double the radius. Well, our radius is our line segment that comes from the center of a circle. And if I have 2 of those, I'll be stretching all the way across the circle, also known as my diameter. And so we would have diameter times pi as an alternate version of our circumference formula. Either of these are fine. I'm usually not thinking of this formula though. I'm usually thinking of this one because I can quickly convert a diameter to a radius if I need to, and that way I only have to have one formula that I have handy in my head. Let's look at some examples of perimeter. So, our first example, we would like to find the perimeter of the following figures. Our first figure is a triangle. It's a non-right triangle at that. And we've been dealing a lot with non-right triangles recently. But for those we were finding missing lengths and areas, here we're just finding the perimeter. Well, you'll notice that there are these tallies on 2 sides of this triangle. And those are geometric symbols that let us know these are congruent or the same length. And so if the one at the top is 13.9 meters, the one at the bottom should also be 13.9 meters. And then the other side is labeled as 4.3. Well, perimeter, we're just going to add these all up. Now, I could add up 4.3 plus 13.9 plus another 13.9. And that's absolutely fine. That gives me an answer of 32.1. And that would still be meters, not meters squared, because we're not finding area or anything like that. Now, in general, whenever I see something that's used more than once, I go straight to multiplication. So I know there is only one 4.3 involved, but there are 2 13.9s. And I can plug that in my calculator and not have to worry about the 13.9 twice, just 2 times whatever I have. And that also, of course, gives me 32.1. So there are shortcuts you can do. If you have doubles or triples of something or more, you can multiply by the number of those that you have. And that way you don't need to keep putting in the same values over and over in the calculator. In this particular case, it's not a huge time saver. It saves you a couple strokes on the calculator, but that's the idea. Now let's take a look at the one over on the right. Now we have just a simple sort of rectangle or parallelogram that's going on there. But instead of using numbers, they're using variables here. Once again, we can simply add up all the sides. We have two pairs of congruent sides. The single tallies let me know those are the same or equal, and these would also have an equal length or be congruent. So I can take the 3x that I have on the bottom, but I know there's another 3x on the top. And then I'm adding when I'm doing perimeter, and my side on the right is x minus 4 centimeters, and I have another one of those over on the left. Now this x minus 4 that's in parentheses, the parentheses isn't doing much for me other than just grouping to say, even though there's an expression here, there's this minus sign with two terms, x and 4, it's still just one measurement. But they aren't really doing anything else. They aren't indicating multiplication or anything like that. So if I want, I can just start adding all this stuff together. Well, right away, I've got a 3x here. I've got a 3x here. I have a single x here and another x there. Well, if I have 3 x's plus 3 more x's, that would get me up to 6 x's there, plus 2 more x's. So a grand total of 8 x's. And then I have the minus 4 and the minus 4 again. Well, if I take away 4 and then add a negative 4 to that, I end up with taking away 8 total. And so my total perimeter would be 8x minus 8 centimeters. Now you might be saying, what is the x? We don't know the x, but all someone would have to do is give us that x, and then we could tell you how big that is. And this would be really helpful if I was doing like a scale drawing. And whatever the scale is, like if I wanted to make this 2 times bigger, I could let my x be 2, and then everything would be twice as big as I had it originally. But that's all we really have to do at this point, 8x minus 8. Now, as I showed on the previous example, what we can also do is we can take the two sides that we have. We had a 3x, and we also had this x minus 4, but there were 2 of each of those. So I can simply multiply both of those by a 2. And arguably, it might even be more work as we get going, but right away, as I distribute the 2 times the 3x, I end up with 6x. And then here, when I distribute my 2, I end up with 2x minus 8. You can already see that 8 appearing that we had in our final answer, and then we would just be combining the 6x and the 2x to get 8x minus 8. So an alternate way to do it. I don't know if it's faster. I don't know if it's better. It's probably what I would do, but it gets you the exact same answer. All right. For this one, we're continuing on finding our distance around our figures. We're finding the circumference / perimeter of the following figures. Well, for the first one, it's definitely circumference that we're finding. It's a circle. And so I'm going to start by writing down my formula. Circumference is equal to 2 pi r. Well, this is a pretty straightforward one because they've already given us our r. How do we know it's the r? Because it's the radius. It starts at the center of the circle and extends to the outside of the circle, or the circle itself. And so I'm going to have 2, which is a constant, never changes in this problem, pi, which is also a constant in this problem, and then I'm simply going to replace my r, which is 5. And so I end up with 2 times pi times 5, or 2 times 5 is 10, so I have 10 pi. Now that's an exact value, and you can leave your answer like that unless it says otherwise. Now, a lot of times if we want to make a measurement, working in terms of pi is not convenient, but if we want the most accurate answer possible, that one has not been rounded, it's totally accurate, and it's totally fine to do that unless the directions say otherwise. Now, what is pi? Pi is a number a little bit more than 3. So if I needed to estimate this, even without a calculator, 10 times a number a little bigger than 3, I would expect this to be a little bigger than 30. 31.4 to be precise if we actually plug this in. And again, you can use your calculator and then round that to 3 significant figures, but you will end up with 31.4 meters. All right, moving on to the next one. Now, generally the directions on this one would say find the perimeter, but really we're doing a hybrid here. We're combining perimeter and circumference. So we want to look at what we have. There's this dotted line, and I'm going to trace it with a blue pen here to show that we have essentially a rectangle at the bottom. And so let's start by finding the perimeter of that rectangle. We have 10.8, and we have 4.2. Now, you'll see that these are marked congruent here. So how many 4.2s do we have? We have 2 of them. So I can multiply this by a 2. And then for perimeter, I always want to add up. Now you might say, why didn't you double up the 10.8? Because if this is a rectangle, the 10.8 would also occur twice. And it does. The 10.8 is on the bottom, and it's also right where I just had that blue pen mark right here. But this part is not on the outside. The outside of the figure that I'm actually trying to find the perimeter of goes around here, and then it just comes down to these three sides of the rectangle that we have there. So I don't need that top side because it's not on the outside of this hybrid figure. So what I'm going to do is simply add these up, and I get 19.2, and that would be meters. But that's not my whole figure. I still have to deal with this curved part up here. Now the curved part up here is clearly part of a circle, but it's not the whole circle. It's what we'd call a semicircle, or half a circle. So if I go to my circumference formula, which is 2 pi r, I right away can say I only want half of this. So I can multiply all of that by 1/2. And some of you may be noticing already, since I'm multiplying by 2 and 1/2, those are sort of going to cancel out. Also, then we need to say what actually is our radius. Our radius would be this value that goes from here to the edge of the figure. Well, they didn't give us that value, but they do give us that figure from the or that measurement from the rectangle, which is 10.8. So we would know that this whole diameter here is 10.8. Half of that, or 10.8 divided by 2, would be equal to 5.4. So that would be our radius. So I can plug that in. So I have my circumference is equal to 2 pi times 5.4 times 1/2. Now, if you wanted to use the alternate formula that just had diameter right from the get-go, you would have 10.8 pi times 1/2. Now, the 1/2 and the 2 are going to cancel each other out because 1/2 of 2 is 1, and then 1 is an identity. So we really end up with 5.4 pi as my answer here, and that is nice and exact, and that would still be in meters. However, I need to combine it with this decimal down here, and we could leave our answer as 19.2, which was the three sides of the rectangle, plus our curve, which half of a circle, and again, we had that half embedded in our formula, so it was 5.4 pi, and that whole thing would be meters. And now we just have an expression for our answer similar to what we did on the previous one when we had x's involved. Or we can round this and get a decimal. And all I'm going to do is just type 19.2 plus 5.4 times the pi key on my calculator. And I end up with 36.2 approximately. All right, moving on to the next one. Here, no picture drawn, but it's asking me to find the radius of a circle with a circumference of 11.7. So for once, we're not finding the circumference, we're finding a part of a circle. So what I would do right away is write my formula down. I know that circumference equals 2 pi r. We're looking for r, but we already have circumference. So let's start filling in. I have 11.7 equals 2 times pi times my radius, which is what I'm trying to find. Now, in any algebra problem, I'm trying to get my variable alone, which would be r. What's keeping r from being alone? It's getting multiplied by two things, 2 and pi. I'm going to do this in one step. Since I'm multiplying a 2 and a pi, I'm now going to divide the 2 and the pi, which will cancel these guys out. But whatever I do to one side, I have to do to the other. All right, so now when I enter this in my calculator, I do want to make sure that this whole denominator is in parentheses. So I'll do 11.7 divided by parenthesis 2 pi close parenthesis. And I end up with approximately 18.4. And my units would be meters, because that's what they gave me. All right, I think I'm going to end our lesson here. I thought we'd get on to area as well, but we will save that for the next video since we're just about at the 15-minute mark. All right, till next time.